to academic lecture over graphing absolute value functions via vertex form. Okay. All right, here we go. A little warm up. Okay. What's the parent function of the absolute value functions family? Yep, exactly. F of x equals the absolute value of x. Okay. So let's describe how does the graph of A compare to my parent function graph. Yeah, Kate. What's that? Well, the parent graph also has absolute value, but like, what changes? The putting that -5 in there changes what about the original graph? So yeah, translate right 5. Yeah, so this is just due from yesterday. Translate right 5, okay? And then Megan, for B, can you tell me what happens to the graph in B? Yeah, translate up, down. Translate up, 9. Translate up, 9, okay? Good stuff. C for C. Kate Moriarty. What happens? Parent graph. Doesn't go down. That's a good guess, right? So that would be if we did -1. This is what? Let me see. Yeah, because we did times -1. Does that make sense? The difference? Yeah. Reflects across my horizontal axis. My horizontal axis. Okay, that's what happened there. For D. We've got 2 transformations, right? What are the 2 things that happen for D?
Something happens with the 3 and then it goes down by 2.
Yeah, say something happens with the 3.
Yeah, I forget what happens with
So it's a 3, right? That's a 3 times. So a times, right, is going to either compress or stretch, right? This one's going to stretch, right? Because the absolute value of 3 is greater than 1, yeah. So vertical stretch by 3. And then translate down 2. Translate down 2. Wow, okay. All right. Chris Klug, you got E for me? What happens here?
Going to go up 6.
So that +6, is it inside my absolute value bars or outside the absolute value bars? Inside, right? So plus inside my absolute value bars, those are plus.
Goes right.
Yeah, so you go left or right here for plus?
Right 6.
It's going to be plus. It's the opposite when it's inside. Yeah. And then what does the 1/4 do?
It's
Yeah, so you're on the right track for sure. What's the one? Is it? It's going to either compress or stretch me, right? Which one does it do here?
it's gonna stretch.
So 1/4. Absolute value of 1/4 is.
Compress.
Yeah, it's 1/4. Yeah, so compress. I'm going to get compressed because it's a vertical compress. I'm going to get vertically compressed by 1/4. It's a compression because the absolute value of 1/4 is less than 1. That makes sense. All right, Ian. There's 3 of them here. Ian Clark. No. All right, what happens here?
We do left 7
Yeah, translate left 7. Nice.
and down 2.
Yeah, so translate left 7. I want to say you're going to reflect and then translate down.
Reflect across.
It still follows PEMDAS. So the x plus 7, you're grouping. That happens first, and then your reflection, right? Reflect across the x-axis.
And then down.
Yeah. It's way down too. All right, good. It's a good warm up. Okay. So, right, there's 3 things we can do to our graph, right? We can translate it left or right or up and down. We can reflect it, and we can also dilate it, right? Okay, So we can actually write a general form for every possible absolute value function if we say, okay, take my parent graph, dilate it by an unspecified amount. We'll call that A. We're going to take my parent graph, right, our parent function, okay? We're going to dilate it, right? We dilate by A, some unspecified amount A, okay? We're going to translate left/right by some unspecified amount H, right? And then we're going to translate up and down by some unspecified amount K. Okay. All right. And then we reflect based on whether A is negative or positive. Reflect if A is less than 0, okay? So how would we write this transformation then? Anyone know how we would write that transformation? We dilate by A, translate left/right by H, and up and or down by K. What would we do? What's that? So the equation of my new graph would be this: be f of x equals A times the absolute value of x minus h plus k. Okay. Every single absolute value function can be written in that form. In this form, f of x, vertex form of an absolute value function is A times the absolute value of x minus h plus k. Okay. The vertex. Anyone have any guess what the vertex would be? If an absolute value function is this form, right? The vertex is going to do what? So this vertex starts at 0, 0 in my parent function. Then what does it do? Where does it go? It goes to the right by h, and it goes up by k, right? So it's going to be h comma k is my vertex. Okay, it's going to be really useful when we're trying to graph these, okay? Okay, and then the slope on the right side is going to be a. The slope on the right side, right, of the line that comes out of my vertex to the right, the slope of that's going to be a. So Chris was onto something there. And then the slope of the left side, on the left side of my vertex is going to be negative a. It's going to be negative a, okay? All right. Good stuff, okay? So here, what this does right here, this makes graphing my absolute value functions a lot easier. It makes it a whole lot easier, okay? Makes it a whole lot easier, okay? Instead of having to make a t-chart, we can just see where our vertex moves to, and then we can use my A to get the slope of the two lines coming out of my vertex, right? Okay, so here, let's label this, okay? So I'll zoom out so we can still see our vertex form here. What would my H be here? What's my H equal to? -2. Not -2, so it's minus H. So it's going to be the opposite of whatever's inside here. +2, yeah. H is +2, right? What's my K? What's my K? K is -4, yeah. So H is the opposite of whatever is inside my absolute value bars. K is the same as whatever is outside. Does that make sense? Yep. Okay. All right, good stuff. So that's my H. What's my vertex then? If my vertex is H comma K, what's my vertex here? 2, -4, yep. Okay. What's my A? My A is technically 1, right? So the slope of the left side is going to be negative that, so -1, and then the slope of the right is going to be +1, okay? So you guys see how I can graph this then? All I have to do is plot my vertex. My vertex is at 2, -4, so right 2, down 4, okay, so right here. I just plot my vertex. And then the slope of the left side is going to be -1, so I can plot another point, left 1, up 1, okay? Slope of the left side is going to be -1. Okay? Slope of the right side is going to be +1, so up 1, right 1. done graphing, okay? You see how that's a lot easier than making a T-chart, right? So math exists to make things simpler, right? How we feel about that? Let's do more examples. Do some more examples. Lance, what is my H for number 2?
-5.
-5, right? H is the opposite of whatever is in my absolute value bars here, right? What's my K? What's my K, Berhanen?
0.
0, right? There's technically a plus 0 here, so K is going to be 0. Good job. And then Thomas, what's my A?
3.
3, yeah. 3, yep. So my vertex here is what, Jade? What's my vertex? Good job, yeah. 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 So my A is 3, so the slope of the left side of that is -3, is the opposite of A. The slope of the right side is going to just be whatever A is, so +3, okay? There you go. That's all we need. That's all the info we need to graph this, okay? Oh, that's all the info we need to graph this, okay? So I'm going to plot my vertex. So what's that? -5, 0. So left 5, 1, 2, 3, 4, 5. Up or down 0. Probably the left, aren't I? Okay. Slope of the left is -3. So to put a point to the left here, I go left 1, up 3. Right. Put a point to the right, I go right 1, up 3.
Why would you go 1? Why would you go 3?
So slope is rise over run. So if that's equal to 3, or 3 over 1, that means I go up 3 and then I run, or I go over 1. Right? Cool, and then I want to connect my dots. Connect dots. There you go. There's my graph. Okay. That's all I gotta do. Are we okay if I move on to number 3? Number 3. Okay. All right. So number 3. What's my H here, Sam Rice? Yeah. What's my H?
1 negative.
-1. Yeah. It's the opposite of whatever's inside the absolute value bars. Okay. Monica, what's my K? Yeah. -2. All right. Megan Henfling, what's my A? 2. +2. So the slope of the left is what, Kate Moriarty? -2. Naomi, what's the slope of the right? Yeah, +2. Good job. So my vertex then, Will Fletcher, is what?
-1,
Yeah. So I plot my vertex. So left 1, down 2. Plot my vertex, okay? And then the slope of my left is -2, so to plot another point on the left, I go left 1, up 2. And then to plot a point on the right, I go right 1, up 2. And I can just play connected dots. There we go, shouldn't be too bad. Hopefully we can all crush the quiz next week, okay? That's it. Yeah, I'm done graphing. Okay. Number 4. All right. Number 4. Taylor Jones. What's my H? +6. Yes. Jack Schneider. What's my K? 0, right? Because the technically +0 there. What is my A, Ruby? -1. Yep. So my vertex is going to be 6, 0, because that's H, K. The slope of the left. Deny it. What's the slope of the left side of my graph going to be? Yeah, +1, right? Yeah, it's going to be, so the slope of the left side is always the opposite of whatever A is. So here A is -1. opposite of negative 1 is positive 1, so the slope of the left side of my graph is going to be positive 1. Slope of the right then is always the same as a, so it's going to be negative 1. And that makes sense because this is going to be an upside down v, right? Yep. So I plot this, okay, plot my vertex, right 6, 1, 2, 3, 4, 5, 6, up or down 0. Okay. Slope of the left is positive 1, so I'm going to go down 1, left 1. Slope of the right is negative 1, so down 1, right 1, okay.
How do you know to go down instead of up?
On the left side. Yeah, so let me think of the best way of explaining that. So as I'm moving along the left side, right, I have all these points here. Kate. Great, that's a really good question, by the way. I have all these points here, right? The slope of the left side is positive 1, right? So when I go from a dot on the left to a dot to the right, I've got to go right 1, up 1, okay? So when I'm plotting dots starting from the vertex and going backwards to the left, I go down 1, left 1. Does that make any sense? No, okay. Okay. Trying to think of another good way to explain this. Try thinking about, like, so look at the function here, right? It's negative, right? So you know your graph's going to be a downward. It's going to be an upside down v.
Oh, is that? So that's why.
Yeah, it's going to be an upside down v. Since there's a negative in front, it's going to be an upside down v.
So if
you,
it was positive.
yeah, you know the
outside
slope of the
of
left side is going to be positive.
Okay.
So to plot it, starting from my vertex, I've got to go down and to the left. So this has to have a positive slope here.
Okay.
And then the right side has to have a negative slope because I need an upside down v. Does that help?
Yeah.
Cool. And then I'm done graphing that one, actually, so that's good. That's good. All right, Chris Klug, what's my H here for number 5?
It's what?
Someone want to help him out?
Negative 1.
So it's the opposite, whatever's in here. Yeah. No worries. Negative 1k is what, Samrise?
Wait, what was it?
What's k here?
It is negative 1.
Yeah, nice. Cool. Sophia Fisher, what's my A? 2/3, yes. 2/3. So my vertex is negative 1 comma negative 1. It's going to be whatever h is comma whatever k is. A is 2/3. So the slope of the left equals negative 2/3, right? It's the opposite of whatever a is. And slope of the right is positive 2/3. Positive 2/3, okay? There you go. There it happens. Okay, so to plot this, I'm going to plot to graph this, I'm going to plot my vertex. That's negative 1, so left 1, down 1. Good job. Slope of the left is negative 2/3. Okay, so that's rise over run. So I'm going to go to the left 3 because I ran 3 and then up 2. Okay. We can check that, okay? So from this dot on the left here, right, from this, I'm going to have to use a highlighter. So from this yellow dot to my green dot here, right, I need to make sure I rose negative 2 and ran 3, right? 2/3 rise over run. So the rise is negative 2, the run is 3. Okay? Go to alpha 1 to do. Okay. And then 2/3 to the right is up to right 3. Okay. And my dots. That's it. Okay, Any questions on that one? Hopefully this isn't too challenging. All right. Jack Schneider, what's my h here? 0, right? Yeah, there's technically a plus 0 inside those absolute value ones. Okay. Confused by that? Okay, Lance, what's my k?
7.
7. What's my a, Berhanu?
Negative 3/4.
Negative 3/4. So the slope of the left side, Ian Clark, what's the slope of my left side?
0.
The slope of the left. What did we say the slope?
7.
It's going to be the opposite of whatever a is. So what's a?
Positive 3/4.
Yeah, so the slope of the left is going to be positive 3/4. So the slope of the right is going to be negative 3/4, right? And that makes sense, right? We have a negative out front here, so it should be an upside down v. So start off, plot my vertex. My vertex here is 0, 7, right? H, k. So we're not going to go left or right at all. We're going to go up 7. 1, 2, 3, 4, 5, 6, 7. Right? Plot a point to the left, right? It's going to go, it's 3/4, okay? So we're going to go down 3, left 4. Okay? Point on the right, down 3, right 4. Connect your dots. Connect these dots. There you go. You confused by this? Okay, if we move on. Okay, good stuff. Graph each piecewise function. Piecewise. Okay? Scary. Alright, so we're going to do the same thing that we've been doing, except we have this new method for graphing my absolute value, okay? What's the first step? First thing I do, Thomas Mann, when I graph piecewise is what do I do?
Draw a border on negative x.
Yeah, exactly. So draw a little border, I like that. A little vertical boundary there at x equals negative 4. And then deny, what do I need to do now?
X plus 3 equals 0.
What's that?
X plus 3 equals 0.
Okay, so can I graph the top one first? Are you okay if I do that? So I want to label both, right? So yeah, the second step, right, I label both my functions, right? I'm going to have the pink graph and the blue graph. And then I label on my graph paper, on my graph axes, where each graph is going to go. So the pink graph is going to go where, Jade? To the left or to the right of that yellow line? To the left, yeah. So I'm going to mark that. I mark my two functions, and I mark on my axes where the graph of each one is going to go. All right, so there's my pink. So let's graph my pink function, okay, the whole thing, 2x plus 7, so that's y-intercept of 7, and then it goes slope of 2, right? So if I go left 1, down 2, that's going to be my slope. Do you guys see how going left 1, down 2 is the same thing as going right 1, up 2? Okay, cool. I know how hard that was to see, okay? Good, and then next thing I got to do, Kate Moriarty, what do I need to do here?
Graph the 2.
So do I just leave the pink line where it is?
Oh, no.
Yeah, I got to get it out of the blue region, right? Yeah, so I erase it. Then there's one thing, I'm almost done. Right, we just got to put the cherry on top of my pink function. What do I need to include, Sam Rice? Open circle, yeah. So on that yellow boundary, I get an open circle. Why is that, Sam?
Because it's not equal to.
It's just a less than, if x is less than negative 4, yep. Cool, now, Kate Moriarty, now I can graph my blue function, okay? So we're going to use the new method we did in class today to do this, okay? So Kate Moriarty, what's my h?
-3.
-3. Taylor Jones, what's my k? 0. Right, Monica DeSanto, what's my A? 2, right? So the slope of the left equals -2. Slope of the right equals +2. Okay. So my vertex here is -3, 0, right? H, K. Okay. And then, so let's plot my vertex. So left 3, up and down 0. Slope of the left is -2, so I'm going to go left 2, up 2. No, sorry, I'm going to go left 1, up 2. I'm so sorry. Okay. Slope of the right is +2, so right 1, up 2. Okay. Let's play connect the dots. There you go. Okay. So then I need to do what here? I need to erase the blue part that's in the pink region. Get rid of it. Gotta get rid of it, okay? And then on that yellow boundary line, Naomi, do I get a solid dot or a hollow circle? Solid dot, yeah. And that's because it's x is greater than or equal to -4, okay? All right, good. Now, these notes don't have it, but this is a great opportunity to review domain and range because I think a lot of us are still confused on that. Okay, so domain. Domain. So when you're graphing domain, right, domain is what?
Top one and bottom.
Yeah, exactly. So it's all the x values that my graph passes through. Domain is all the x values that my graph passes through, okay? So if we think about this, right, the x values that are going to be in your domain, if you take an imaginary vertical line and slide it left and right across your graph, the x values in your domain are going to be all those vertical lines that some part of the graph passes through, right? Is that an okay way of thinking about it? Some, right? So if I start, right, if I put my vertical line here and I slide it to the left forever, right? This pink arrow points down and to the left forever, right? So going all the way to -infinity, right? Every single vertical line has a part of the graph passing through it, okay? So my domain starts at -infinity, and -infinity always gets a parenthesis, okay? And as I'm sliding, right, let's slide my vertical line, right? I'm sliding my vertical line to the right, okay? Right? We know here to the right of -4 that there's going to be some part of my graph passing through each vertical line to the right of -4 here. What about on -4? Do I need to skip -4 or no? No, right? Because when I have my vertical line here, this solid dot here, is part of my graph and it's on. It passes through that vertical line. So my domain is all reals because I did not skip, right? Every vertical line I could possibly draw on this set of coordinate axes has part of the graph, at least a part of the graph passing through it, okay? Does that help at all?
Yeah.
Okay. Range, right? Range is just like domain, except what? It's up and down, yeah. So for range, think about like horizontal lines, okay? So the range, right? It's going to be all the y values that some part of my graph passes through, or all the horizontal lines that some part of my graph passes through. So if I start, right, if I go down from here, right, this pink arrow points down forever. So every single horizontal line I could ever possibly draw has some part of this pink line going through all the way up to here, okay? So I start at -infinity for my range. Okay, start at -infinity for my range. Okay. I go up, I go up, I go up. And then what happens here from y equals -1 to y equals 0? What happens there? It jumps, right? For these vertical lines here, right, there's no part of the graph that passes through them. So let me draw those in. Right, or if I draw a horizontal line, I'm sorry. right? If I draw a horizontal line through there, right, there's no part of my graph which passes through it because the pink line stops here and the blue line doesn't start till up here. So what do I need to do then? In my interval notation, I need to write what? Yeah, so I need to write, not u. Okay, what do I write for this in this right part of this parenthesis of this interval? So it stops at -1, goes all the way up to -1. That -1 is going to get a parenthesis. Why does he get a parenthesis and not a bracket? There's an open circle there. Then a u, and then what comes next, Jack? Not infinity, the next. So look what I've got here. 0, yeah. 0 with a bracket or a parenthesis? Why does he get a bracket? Solid dot, yeah, call it closed circle. And then comma, positive infinity, right? Does that help at all?
Yeah.
Okay, cool.
Good stuff.
So
Good
you
st-
don't do the U if it doesn't like.
If it never skips, yeah, you only have to do the u to like show that like either your domain or your range skips something. Okay, write the domain here from left to right. We never skip. We never skip from left to right, but going up and down, right? We skip this little region right here, right?
And then will it be the same thing to the domain
If it skipped, yeah. That's interval notation. Yeah, we're gonna do interval notation in this class. So some of the homework answer keys have like what's called set notation. All right. I think another teacher in like another school year made them. We're always gonna do interval notation. Okay, so stick to interval notation. Stick to interval notation. Right. The big kids use interval notation. I can go more in depth into that, into why, but that'd be beyond the scope of this course. Are we okay if I move on to number 8? Let's move on to number 8. So, yeah, Jade Sloan, what's my first step here? Set my boundary lines. Okay, so -4 gets a vertical boundary. All right, -4, and then Chris, what's my other boundary line?
It'll be 0, so
What's that other, right? If x is greater than or equal to what?
2.
2, yes, it'll be 2, yep. Those are the two, that's what we go off of. There we go. There we go. All right. And then I need to label all 3 lines in my function. So label this, the top line will be the pink graph. Right, middle line will be the blue graph. Right, I'll make the bottom line my green graph. Okay. So where is that pink graph going to go? Let's do Will.
Wait, what do you know?
Where does the pink graph go in this? When I graph this piecewise function, where does the pink part go? So where on my coordinate axes am I going to graph the
left.
pink? Yeah, to the left, yeah. And Macy, where does the blue graph go?
in the middle.
In the middle, yeah. All right, yeah. Good. Green graph goes to the right. Green graph goes to the right.
Do you do the border thing if it's the greater than or less than signs? Like when you know
The order, like where to put them or when to put them?
when?
If you're doing it piecewise, or do you mean the yellow? So like right here, do you mean the borders like the dashed yellow?
Yeah.
You always are going to have at least one border when you're graphing it piecewise. You know where to put them based on what comes after
Yeah.
these if statements. Okay, make any sense? Okay, so let's graph the pink. Okay, so that's my absolute value function here. Okay, what's my h? -1. All right, my k is +5. My a is -1. Okay, so my vertex is going to be at it's going to be at -1, 5. Slope of left is going to be +1, right? My a is -1. The opposite of -1 is +1, so the slope of the left is going to be +1. The slope of the right is going to be -1, okay? So let's graph that. So left 1, up 5. Okay. Slope to the left is 1, so I'm going to go down 1, over 1 for the left, down 1, left 1 for the left. For the right, I'm going to go down 1, right 1. Graph that whole function. You guys are about to see why I teach piecewise the way I do. Right, then I need to do what with that pink graph? I need to erase the part that's outside the pink. Get rid of this. So this is why I teach the absolute value the way I do. I have you graph the whole thing, then erase it. Because this shows you that, okay, we did graph an absolute value function, we just cut off the part in the middle of the V, so it almost looks like a line. Right? And then on the border it gets a solid dots. Right? Bless you. Okay, I'm going to try to go a little faster. Horizontal line through positive 3 for the blue region. Oh gosh. Right, and then I gotta erase any part of that that's not inside the blue region. Okay, make an open circle on both boundaries. Green line, right, negative x plus 7, so y-intercept is 7, slope of negative 1. Then I erase any part that's not in the green region, and it gets a solid dot. Okay, so I had to rush to the end of that. Okay, so my domain here is going to be all reals. Okay, range is going to be negative infinity to what's that, 5? Right. Okay, now I gotta show you guys one inequality. Okay, so graphing the inequalities out here. Let's do number 10. Let's do number 10. It's just like the linear inequalities. The graph just looks like an absolute value now. So let's graph this real quick. We got 3 minutes. Okay. So my h is negative 5, my k is...
Wait, your h is 5, right?
Thank you very much. Yep, I made a mistake. I'm sorry. Positive 5. Okay, yeah, so check your work on your quiz, right? Because everyone makes mistakes when they try to go fast. Okay, a is negative 2. So my vertex is 5, 4. The left slope is positive 2. The right slope is negative 2. Okay, so I'm going to plot my vertex. So right 5, up 4. Okay, and then slope to the left is 2, so down 2, left 1. Slope to the right is negative 2, so down 2, right 1. Okay, and then when I connect my dot, before I connect my dots, I need to look at what, make sure I'm doing what correctly. So my inequality symbol, is that a greater than or a greater than or equal to? It's just a greater than, so what kind of line do I need to connect the dots with? Dotted or dashed, yeah. Good stuff. Good stuff. Cool. And then now, so now I'm done graphing, I need to do one more thing that a lot of people forgot to do on the test. Shade. Do I shade above or below the graph here? Above, yeah. Right, because it's y is greater than. This line right here, this dotted line, that's all the points for y equals that function. We want all the points for y is greater than that function. How do we feel about today? Good, okay, yeah. So I think this is the last lesson before your quiz. So you'll take a quiz Tuesday. We'll continue with chapter 5 on Monday. We'll start chapter 5 Monday. We'll quiz over what we did this week on Tuesday. No, like come to the review. Come to like office hours on Monday. We have a little review session. Yeah. Wednesday. Yeah. Oh, I did? Okay. So you would have missed graphing transformations. Did you ever do this homework? Okay, okay. Sorry about that. And I have a lecture on YouTube for it. David Taylor. Lectures on YouTube. Thank you, Mana. Oh, are you done with it? Okay. Oh, sweet. Did you just like switch it out on your own? Okay, good. So you got to the graphic calculator?
Yeah.
Okay. Okay, yeah. So you were in class yesterday. So I wasn't supposed to give everyone. I was supposed to give people multiple classes.
Oh, yeah.
Thank you.
I just wanted to make sure that they didn't leave. It was out.
Oh,
in the
yeah.
hall.
Thank you. Yeah. So Shadio's class did it in 2 different parts, which I was supposed to do, but I didn't. So I'm like, I have more freedom in curving. If that makes any sense. Yeah.
Okay.
Thanks for letting me know, though. Yeah. Where'd you put the other portion? Okay, nice. I didn't even notice it from it. I trust you. I trust you. I don't know.
And when are we taking the 414?
We're gonna do finish 4-2 today. We'll assign the 4-2 homework tonight. You guys will turn it in Monday.
Because it's supposed to be
And then the
Tuesday.
quiz Tuesday. Oh, really? Okay. I'll skip that one. Sorry. I gotta start changing that so you guys know you can trust me. Yeah. So let's think about horizontal lines, right? If I start from negative infinity, right, these all have photograph passing through them. See that? Okay. That has photograph passing through, right? We jump here, right? There's a jump between these two, but for y value, in my range, I only need one part of the graph to pass through. Look at this line, right? Whatever doesn't get covered by these 2 jumps here does get covered by this line over here. Does that make sense? So like right all the way up until +5, this right line, right, passes through. So the jumps don't actually really end up like that. Does that make sense? Because this right, whatever I do jump over here still gets covered by this line. Does that make sense? Okay. In other words, the domain, the range of this function is the same as the range of just this line right there.
Okay, can we just, what's happened? I got new uniform keys last night, because I need to know how many I don't you?
Wheel on the ground, when come out. My lashes are dry.